I'm Sheldon Varco, Membership Manager in New South Wales and South Australia here at Austmine, and I'm looking forward to hosting you for today's METS Tech Talk. Austmine's METS Tech Talks are designed to provide short insights into key solutions, emerging technologies, and innovative processes that are advancing and transforming mining as we know it. For Series 2 of the Tech Talks, we're looking at innovation across the mining value chain, beginning last week with mine planning and design, before moving into topics such as asset management, materials handling, and minerals processing. You can go to Austmine's website to find the recording to part 1 and to register for the upcoming Tech Talks. For today, we'll focus on leading edge innovation, transforming drilling and blasting. We have 5 companies joining us who will each have a 5-minute tech talk to provide an overview of how their solutions are optimizing drill and blast outcomes to drive efficiencies downstream in the mining process. Finally now, I'd like to welcome Nico Swart, Technical Specialist at Dyno Nobel Asia Pacific, to discuss their DigiShot Plus 4G system. Thanks, Nico.
Thanks, Sheldon, and thanks everyone for this opportunity to share some thoughts on electronic detonator safety, especially while there's still personnel on the bench in the line of fire with a loaded bench. Dyno Nobel's electronic offering has been specifically designed with the end user's safety as the highest priority. 2 strict controlled inputs are required for a detonator to successfully initiate. These energies are controlled by the control equipment, and there needs to be sufficient blast voltage and some coded signals and a firing command at the time of initiation for the detonator to successfully initiate. If not, it will fail to save. The operational voltages are split into 2 distinct levels, a no fire and an all fire voltage. The control equipment is therefore designed to ensure that all devices that may be used by the personnel on the bench comply to the no fire voltage. The all fire voltage is only supplied at the time of firing. PCO board logic is tested throughout the manufacturing cycle to ensure that the building state engine operates as it should. After final assembly, the complete unit is tested to ensure that all parameters are operating within set limits, including power consumption, current draw. Looking at the fuse head used in our system, this has been carefully chosen to ensure that it complies to the no fire and all fire energy strategy. In this block diagram, it shows a basic breakdown of the internal components of a detonator. So what we're trying to achieve is, if we have a catastrophic failure where the input is directly connected to the fuse head, that the control equipment used by the user on the bench still operates at the energy level that is below the fire voltage for the fuse head, therefore making it safe for that user. The fire command required to initiate a detonator is not stored in any of the control equipment's firmware. Pardon, this has been encrypted into the blast card, which is only swiped on the control equipment read via NFC at the time of intended initiation. This also forms part of the high voltage protecting circuitry, so without the swipe card swipe, the unit won't be able to actually raise the system above to the all fire voltage. The current slide shows the internal hardware state engine gates included in our application-specific integrated circuit. Once power is supplied to the detonator, it will do a boot-on test, making sure that all the internal components are operational as they should. The detonator needs to be pre-programmed, which is done during the tagging process or pre-time. The control equipment will then program it, send the arm command, followed by the fire command. And unless the specific sequence is followed, the state engine will revert the dead back to a safe state. So in summary, the detonator only supplied with a safe voltage during testing and programming. So at this stage, we only operate at the no fire voltage. High voltage can only be supplied once the user has retreated to a point of personal safety, At that stage, the smart card will be swiped, fire command will be read, so it will be exposed to the control equipment, which will then send it to the detonator. And only then will the detonator be able to initiate the fuse head successfully. This dual initiation requirements, coupled with other interlocks, like I've said, the state engines, for instance, make sure that our detonators are safe for use while the user is on the bench. I've included this slide as well because it comes up fairly regularly, people asking about what should be done when lightning is approaching. While DetNet prides itself in its safety of our systems, we still feel that when lightning is approaching, the bench should at all instances be cleared, as the energy involved in a lightning strike can overcome the actual safety measurements we've included in our detonators. In this example that I have here on the screen, this was a detonator that was struck by lightning. It fried all the internal circuits, but it failed to initiate. This is not always the case, and there's been a couple of recorded instances in Australia where electronic detonators have actually initiated. So it's therefore always necessary to vacate the blast area when there's lightning approaching. Thanks for the opportunity, guys.
Excellent. That's really great innovation there in the safety process, Nico, and really completes our view today of the drill and blast, of technology solutions in drill and blast. We've gone from productivity and efficiency, environmental and compliance, and also to safety there. So thanks a lot for that. Moving on now, it is time for audience Q&A, and we do have plenty of questions that you've sent through to our speakers. So thanks a lot for engaging with these presentations. Moving on now to a question for you, Nico, and both, you have two questions coming through, but they touch on similar topics. So I'll ask you this one. So first of all, how many detonators can be fired with the blaster? And what happens with radio frequency signals? Can they affect the operation of the DigiShot system?
First question, the total system limit is 16,000 detonators. So it's 400 detonators per channel, 4 channels per commander and 10 commanders. And we do fire these fully synchronized in less than 1 millisecond. So it gives you a full synchronized 16,000 detonators in the system. The second one, on the radio frequency, we do have set limits. There's international set limits of 30 volts per meter that the system needs to be compliant to. We do test ours up to 200 volts per meter. So it's a logarithmic curve that's being used. So we exceed it by magnitudes. So definitely safe for normal use, with normal current transmitters in proximity of the detonator.
Excellent. Thanks a lot for that as well.